Hey everyone, welcome to NFT PFPs by Avaissance. This is PFP generation part 2 of 5. So last time we talked a little bit about the basic composition of your avatar, what the base should compose of and all that. Today we're going to get into a little more in-depth and some more complicated parts of generating avatars for NFT PFPs. The first thing we're going to touch on is how many traits do you need? How I like to think about this is by working backwards from a rough collection size that you think you want, whether it's 500, 1,000, 3,000, 5,000, 10,000, anywhere in between. Once you have that, you can kind of work backwards using permutations to decide how many trait categories you need and how many traits you want in each category. So if you look at the table over here, this shows you a few examples, 5 examples with anything ranging from 6 to 7 categories and how many traits are in each category. So you can see here the permutation column, the far right column shows you how many possible combinations you can make based on the numbers provided in each example. So for example, if you want a collection size of 5,000, I would recommend going with something along the lines of example 2 or 3. The reason being you want much more possible permutations than your actual collection size, because while you can make 6 million possible combinations in example 3 using these number of traits across 7 categories, a lot of them are going to look really similar. A permutation is defined as something that is unique to everything else in this 6 million, but it could be unique by only one small trait. Maybe it's just the background color, maybe it's just the eye, maybe it's just the mouth. So you're not going to have a lot of visual diversity if, for example, you go off the first row here, example 1. So while yes, you can have 30,000 permutations, you probably won't have 5,000 visually distinct permutations that actually look different and give you, different types of rarity and distinction across the collection. So based on the collection size you want, you can kind of work backwards to determine how many traits you need. Next, we're going to talk about conflicts. So conflicting layers and traits is something that happens all the time in NFTs. The more traits you have, the more complicated it gets. This is bound to happen. I would say it probably happens the most with around the head area, whether it's a humanoid or animal avatar. This happens a lot with hair and hat, for example. If you have a ponytail, it might be sticking through the hat, or in some of these examples, you see the mask layer actually going over the hair, or the ear going through the hat. So how do you fix this? Well, one way to fix it, which is the most complex, is to have trait variance. This is usually done with a masking layer, which is something that the art team will have to figure out. So you'll see in these examples, on the left-hand side, both female avatars have a sort of bun or ponytail type hairstyle. If you were to just stick a hat on top, that hair would actually stick through the hat. And you'll see in the example on the right-hand side, that's not happening in either case. And the reason for this is there is actually a hat variant where there's a masking layer of the part that would otherwise stick up through the hat. And you can see the ponytail here is actually flattened a little bit to give it a more natural look. So this obviously is a lot harder to do both on the art side and on the generation side. And you'll need to build in logic in the generation phase that selects the hat variant of that particular hair. If and only if a hat is selected. So, for example, you'll have this beige ponytail, which is the normal variant, and then beige ponytail, which is the hat variant, to make it work with hats. So this is kind of a flowchart to show you what happens. Where let's say that the ponytail comes up, then you have a yes or no check saying, is there a hat/headgear? Yes. Then you need to pull the ponytail underscore cap variant. Is there a hat/headgear? No. Then you can just go with the normal ponytail variant. If you look at the actual metadata and the trait name, it's going to show beige ponytail for both. So this gets into kind of the difference between your generator metadata or internal metadata and the public metadata, which is what folks will see once you've minted. Now, an easier version to handle conflicts is to just avoid them altogether. One easy solution to the hat and headgear issue is by putting them in the same category. So this way, ponytail and cap will never show up together. You see here in the examples on the right, you have the guy with the dreads and the hat. These are all in the same category. So you have the rockstar hair, and then you have the backward snapback. So never will this collection have to deal with potentially having rockstar hair and the snapback, and potentially having the hair stick out through the hat. Same here with the Pudgy's example on the bottom. You have the green mohawk and the blue hat. The blue hat would conflict with the mohawk, but because they're in the same category, you can only possibly randomly select one of these traits in that category at any given time. So by sticking these kind of problem layers all into the same layer, same category, you can avoid a lot of these conflicts altogether. Now, we talked about the different types of metadata. You start with the asset generation, which is actually just drawing the individual traits. And then you need to randomize them in your private metadata, whether you're using software, code, Excel, whatever method you choose, and you assign probabilities to each trait. So if you have the ponytail, you might say, okay, I want that to be a 3% trait, and you go and generate 5,000 rows of metadata. So roughly 3% of that 5,000 will have this hair. But that hair may be matched sometimes with a hat, and sometimes it might not be matched with a hat. So as you guys saw earlier, you have to build in that logic here at the conflict and variant handling stage to perform those checks and say, okay, which version of the ponytail am I going to pick? Am I going to pick the normal version, or am I going to pick the version that works with hats? And then you actually generate the metadata, which is when you have some kind of code or script or engine that combines all the layers based on the data or metadata that you've randomized and combined, and actually draw the assets from each layer to combine and create those avatars. And that's the final stage, the PFP generation process. So you'll see in one generation, you'll actually have generator metadata, private metadata, and public metadata. And the difference between those is just how you organize it internally versus how your software or your script recognizes these names and certain appendices or appendices that tell them what variant or version of this trait it is. And then finally, the public metadata, which is what you want everyone to see on marketplaces when they're filtering for traits, looking at your collection and whatnot. So here it talks a little bit more in detail about what each one is. So you have the private metadata. I'll start from the bottom. This is just the actual file name. It's good to be very descriptive here. So this is a side part underscore black, that denotes the color, underscore M, that denotes the gender. And then you have the generator metadata, which is where you touch on all the different variants and types of that specific trait. So we have a headphone version here, a cap version here, a band version. So you can kind of infer that all these different versions relate to different types of headgear. So depending on which headgear is randomly selected for that particular combination of traits, it's going to pull that version of the side part black hair. And then here, if you look above, this is the public metadata. It's not called anything like side part underscore black underscore cap underscore M. That would be a mouthful. This is where you want it to be more fun, a little less descriptive and more casual. So here we just have it called black comb over, and that's what everyone else will see. But you can see here that all three are actually referring to the same trait or the same asset. So again, this shows the private to public translation. This is the final step where you map your private metadata names to your public metadata names. This is where you can be a little more fun. It can be more unique. It can tell a story. So things like obsidian rifle, magma rifle, Midas touch. These are things that actually appear in the collection and what the public will see. But internally, when you're organizing these traits, it helps to be more descriptive and organized. And the goal for naming these is just internal hygiene and cleanliness, so you don't get mixed up. So the examples I gave below, you might refer to internally as just black underscore AR, red underscore AR, gold underscore AR. So attention to detail is key here. It's very easy to make mistakes when you're dealing with so many hundreds or thousands of traits, trait variants, colors, genders, and whatnot. So it's very, very important to be organized here, and that's where the private versus public names come into play. So you can see the chart here, or the two charts on the right show you an example mapping of what private metadata to public metadata would be. And finally here, this shows you just the power of permutations. We have only 5 traits, 5 different clothing traits for both male and female, and then 5 male hairs and 5 female hairs. So we have the white suit with a black tie, we have the red Metal Gear Solid suit, we have the camo hoodie, we have the black hoodie, and we have the black tank top, and a number of hairstyles for each. And just by using these 5 traits and or 5 clothing traits and 5 hair traits, you can create this many different actual avatars. These were randomly generated. There are some duplicates, so this just shows, when you think about collection size, you want more traits than you need so you can create a more visually distinct collection, even though you could potentially create, X hundred or X thousand actually distinct avatars. So with that, we'll wrap up PFP generation part 2, and we'll see you guys back for part 3.